Hello, my name is Barcenas, and today I'm going to be presenting the Plant Environment Probe for the class of EECE 3015. What the Plant Environment Probe is supposed to do is read the temperature, humidity, and soil moisture content of and around the plant, and then we generate suggestions based on the results of the data that we retrieved through the sensors. For example, if the temperature is too high, we ask you to move the plant to a lower temperature environment. Or if the soil is too dry, we ask that you water the soil. And to do that, we used 4 central components, which I will show and demonstrate to you now. So here's the plant environment probe. As of currently, it's not too pretty because we did not have the time or materials to create a case for it. So as of right now, it's just on the breadboard. Starting off, I want to take a look at these 2 sensors. We have the soil moisture sensor, which you plant this into the soil and it reads the conductivity between these 2 probes. And then we have the temperature and humidity sensor over here, which reads the temperature and humidity around the environment and returns a signal to the PSOC. That's our 3rd component, the PSOC. Its main job in this project is to convert the signals into usable data and generate suggestions based off of the data. And then we want the PSOC to output that to our LCD display. As of right now, you can see that the soil moisture is 0, and that's because it's not in soil, it's in the air, so the conductivity between these 2 probes is 0. We see that the temperature is 19, that's measured in Celsius. Right now, the temperature inside of the house is 66 degrees Fahrenheit, which when converted is roughly about the same. And the humidity is 54, and that is measured in humidity percentage. And the humidity percentage inside the house as of right now is 50% according to the thermostat. So you can see that right now, all 3 of these data values are very accurate. It's still close enough to say that this is measuring accurate data. You can see on the bottom row of the LCD display that there is a suggestion that says that the soil is too dry. Obviously, that's because the soil moisture measurement is 0. But say I were to place my finger in between these 2 probes just a little bit, then you could see that the soil moisture level rises and falls. I'm trying to get it just right. And I'm putting it in the ideal range, which shows that the soil moisture level is 5 because I'm just barely touching both probes. So of course the conductivity is somewhere at a medium. And this is just the control case. As you can see here, I've placed the soil moisture sensor inside of this dirt, which, because it rained recently, is slightly wet, which makes it suitable soil. But the effect I want you to focus on is how the soil moisture sensor has went from level 0 moisture to level 5 moisture, which means it's in the ideal range of soil moisture content in the plant, for the plant. And because the temperature and humidity are within ideal ranges for the plant as well, the suggestion shows that it's good, it's a happy plant. However, if I were to change the soil moisture content right now back to the air, it shows that the suggestion tells you the soil is too dry. That's self-explanatory. But what about if I change the humidity? If I breathe onto the sensor right now, it should raise the humidity up to 80 or 90 because that's how humid the human breath is. So I'll give that a shot right here. You could see it steadily rising. And here you could see how the suggestion changes to high humidity, and it recommends that you return it back to below 60% humidity. And that's because the plant's ideal humidity range is from 40% to 60%. If I were able to somehow lower this humidity environment to below 40%, it would show the opposite. It would show that it's not humid enough and to move the plant to a more humid environment. Temperature-wise, there's not much I can do to show that, but essentially temperature and humidity are interlinked. So if the humidity aspect works in this project, then so does the temperature. Overall, this is our entire project, and I hope this explains better to you who's watching how our plant environment probe works.